These ToF SIMS data are from a core technology instrument, and they are list files so we can produce images and spectra. And what we'll do now is look at an element library that's suitable for looking at the isotopic patterns that you see within ToF SIMS data. So having loaded from the element library directory the exact mass table of isotopes, we can put up a fingerprint showing the different isotopic patterns for nickel in this example, which is indicating that our mass calibration really isn't as good as it ought to be. So what we'll do is create a new calibration for these data, and we'll begin by just indicating one of these nickel peaks, and we'll go for the nickel, the main isotope of nickel, and you select an entry, you indicate that you're going to define the time, and then you click on the peak. So since you need more than one peak in order to do a mass calibration, we'll choose another one. In this case it's sodium, so we'll go through the process again. We'll make an entry in the exact mass calculator page and define time, click on the peak, and that gives us 2 points where we've got mass time bin relationships defined. And when we calibrate, you can now see that the isotopic markers show us that we have a reasonable calibration now. And you can see also for here in the case of potassium there are isotopes, and there's a peak here that looks like it's lining up quite nicely. So the next step we'll do is use these peaks and define some regions, then use these regions to create images from the data set. And the idea is that if we've got our masses calibrated correctly and we know what they are, then we ought to be able to see some kind of spatial information that correlates with these mass peaks. So we'll begin by adding sodium and potassium regions, and once we have these we'll do the same for nickel, and once we've got the nickel peak we can choose another element where we are not quite so sure about what we've got. So let's now move to where we think there might be a little bit of copper. So these are not big peaks, they are relatively small peaks, and we want to find out whether this is copper or some other molecular form of ions that have been collected. And you can see it's definitely not pure copper here. There are other forms of molecules that are within these data. So the theory is that we've got some copper. So let's put up a region on the copper. That's the main isotope. And now we will find another isotope of copper. And having selected two isotopes of copper, we ought to get the same image from both. If these are other materials that are arriving at these masses, then potentially they will not line up. It's not absolutely definitive that if you get the same image that you've definitely got the two isotopes, but if you don't get the same image then you know that you've got a problem. So these are small peaks, and so there'll be low intensity images, but nevertheless we can calculate from these regions sets of images that should correspond to the peaks that we used in the calibration, and also these two copper peaks which ought to look the same. So having obtained these images, the next step might be to try and improve the obvious spatial information by doing some filtering. That is to say, we'll remove peaks or spikes in these images that don't really correlate with signal. So that's the potassium, and that's a copper peak. And indeed, when I show you the combination, you can see that the copper two isotopes produce very similar images. So having done this, let's go the other direction, that we have a copper image, or we believe we've got a copper image. So we can now mark up this copper image with different colors for the different intensities of the copper. So I've selected now a range of intensities that correspond to high intensity copper, and another one for low intensity copper. And the idea is that we will then define this as a mask so that we can create lookup table spectra. That's to say, green pixels will generate one spectrum, red pixels will generate a second spectrum, and we get two new VAMAS blocks corresponding to the two lookup tables. And if we start to manipulate the display, well, first of all we'll calibrate, and then we'll manipulate the display so we can have a look at where we think these copper peaks ought to be and how well we have partitioned our signal based on the image. So here we have the two spectra, and let's zoom in and try and identify where the copper peaks are. I have to do some moving around here using these toolbar buttons to small steps, big steps, until we find the 63-65 region. Zoom in, and there we can see this is where there was low intensity copper. And there are the markers, so we still look like we have some copper even where we had low intensity. And we'll now display the lower tile using the same range of masses, and we can see now we have indeed partitioned the data according to red and green, where we've got copper and less copper.